So we've been using these area models that we did in the opener here. We've been talking about them for a few weeks now. And I've been saying all along, we're going to use these to do something else. We're going to use them to do something called factoring. And we're going to start introducing that today. So we're going to look at these area models in a slightly different way. All right, what I want you to do, though, with the opener here, while I have it up, is just look at what we have here. And notice that in the problem that we have a parentheses times a parentheses. So we have something times something equals something else. So these two things that we multiply together here, those are the factors. We multiply one factor times another factor, and that equals the product. Now, the two factors in the area model become what? We have it labeled here. The first factor is the height, and the second factor is the width. And then the answer here, the product, is what? In terms of the rectangle, what is this answer? It's the area. All right, so we have height times width equals area. What we're going to do today is we're going to start using this rectangular area model, but we're going to start doing it backwards. We're going to know what the area is, and we're going to try to figure out what the height and the width are. All right, so in these area models, we're doing all the same stuff. It needs to have all the same things in it, but the problem is going to be given to us in a slightly different way. So if we look at this problem here, the first factor, the first thing we're multiplying is going to be the what?
2.
It's for the rectangle, what is that? That's the height. And then the second factor, which we don't know what it is, there's some blanks in there, that's going to be the width. And then the answer, this right here, is the area. So we have height times width equals area. So if I fill in everything I know into this area model here, is this 8c plus 10 going to go across the top like we were doing before? What does go across the top here? The width, right? This is not the width, this is the area. So since this is not the width, we're not going to put it up here. We're going to put the area inside of the rectangles. Remember, inside of the rectangles, we always have three things. We have the height, the width, and the area. Now, I'm going to do this in a way where I'm going to set it up just like the area models we've been doing before. So inside of every one of these rectangles, I want the height, I want the width, and I want the area. Okay, so I'm going to put the area down below, 8c. And why do you think I'm just putting the 8c there? Where's the 10 going to go? In the other box, right? So each term in the area is going to get its own rectangle. And so I'm going to write it like this, 8c and 10, so that the total area here is the area that was given to us in the problem. All right, now what we need to do is we need to figure out what those widths are so that we can fill in the blanks here. All right, what do we know about these two rectangles here? I don't know the widths, but I do know the area and also the height. So what I can do is I can start by setting this up and say the height times whatever the width is. I don't know what that is yet, but we're going to figure that out here pretty quickly. And that's going to give us an area of 8c. And the height of this rectangle is also 2. So I can say the height times the width, which is unknown right now, we don't know what it is going to give me the area of 10. And at this point, all we need to do is figure out what we multiply by 2 to get each of those things, to fill in the blanks. What do I multiply by 2 to get 8c? Jordan? 4c, exactly. So we multiply by 4 to get the 8, and then we multiply by the c to get the c. So 2 times 4c gives us 8c. So we're just filling in the blank here to figure out what that width is going to be. So since the 2 is the height, the 4c is the width. And what I'm going to do is I'm going to label that up here also. All right, then we go over to this other rectangle. I know the height is 2. I know the area is 10. I need to know what the width is. What's it going to be, Jack?
5.
5. Why?
Because 2 times 5 is 10.
Because 2 times 5 is 10, exactly. So we're figuring out what do we multiply by 2 to get 10. And that's going to be 5, and that's the width of this one. Okay, now, if you look at the area model, everything in the area model is filled out just like it was on the other problems we did. We have the height and the widths of the rectangles on the outside. We have the height times the width equals the area in every rectangle on the inside. All right, now the only thing I have to do is fill in the blanks here. What do you think is going to go in here? 4c plus 5. And that's just the widths of these individual rectangles here. So the next example is really similar. I want you to go ahead and give that one a try on your own. So when we set up our model here, where's this 5 going to go? It's going to go over on the side. That's the height of the rectangle. That's the height of the whole rectangle, but it's also the height of each of the smaller rectangles. What about the 15D plus 35? Where's that going to go? Yeah, those are the areas of the rectangles. That's the important thing to remember here, is that the answer to the multiplication problem is going to be the area of the rectangle. So this is going to be 15D plus 35. And I usually just write the areas down toward the bottom of the rectangle so that we can write the height times the width up toward the top. So then I know that the height of this rectangle is 5, so I'm just going to start by writing in here 5 times something. And I know the height of this rectangle is also 5, so I'm going to write in here 5 times something. And I just need to fill in the blanks. Now, Taylor asked me a good question. Can't we just divide to get that answer? What do you think? Yeah. So we're figuring out what we multiply by 5 to get 15D. But that's really the same thing as saying, what is 15D divided by 5? Well, what is 15D divided by 5?
3D.
3D. And what is 35 divided by 5? 7. All right, now, we're not quite done with this model. We're missing something. We do have a height, a width, and an area inside of every rectangle. We have the height out here, but we're missing the widths across the top, right? What's the width of this one?
3D.
3D. That's what we figured out in the first one. That's what we multiplied by the height. And then what's the width of this one?
7.
7. So now I can use that to go up and fill in the blanks. So what are we going to have in here?
3D plus 7.
3D plus 7. So I think those are easy enough that we can make it a little more complicated on you, right? Doesn't this look fun? So let's fill in what we can here, using what we know about this. The first factor, which is this right here, is going to be the what?
The height.
That's the height. And the second factor is the width. And the answer, the product, is the area. Now, if you remember, when we multiply two terms by two terms, usually what happens is two of them combine. You guys remember that? So we have 4 areas here, but we only end up with 3 terms because 2 of them combined. Which 2 usually combine, if they do combine? The ones that usually combine are going to be this one here, bottom left, with the top right one. All right, so I'm just going to highlight those so we remember. Those 2 are going to combine to give us which one of these terms? The 10e squared, the 19e, or the 6?
The 6.
Yeah, those are going to combine to give us that 19e. All right, where's the 10e squared going to go? So usually the first term comes from this top left box. So I can go ahead and put the 10e squared there. And where's that 6 going to go?
At the bottom.
That's going to go in the bottom right one. That usually comes from that last rectangle there. The trouble is, this 19e needs to go between these 2. And I don't know how much of it goes in one and how much of it goes in another. It could be 18e in one and 1e in the other. It could be 17e and 2e, or it could be 14e and 5e, or it could be 10e and 9e. I don't know. So I'm going to have to use some other stuff, and I'm going to have to figure some things out here. And we are going to have to maybe do a little bit of guessing. But there is one more piece of information I can fill in first. What is that? I know part of the height is at 2e, right? So I know part of the height is 2e, so I'm going to put that there. And I know that's the height of this rectangle, and I know it's also the height of this rectangle. So let's use that to figure out as much as we can to start with. Since the 2e is the height of this rectangle and this rectangle, what can I do with it? I can multiply 2e times something to get this area. And I'm also going to do 2e times something to get this area. All right, now this doesn't help me out a whole lot because I don't know what the area of this one is yet, but I do know this one. What's the width of this one going to have to be to give us an area of 10e squared? 5e. Okay, so I'm going to put the 5e in here, which means then that the width of this right here is what? What's the width going to be up here? 5e. And there's one other thing I can do. Since the width of this one is 5e, what else has a width of 5e? The one underneath it. So I know that this one right here is going to be something times 5e. We've done as much as we can at this point without really having to do any guessing. The trouble is, I don't know the area of this one, so I can't figure out the height here. I don't know the area of this one, so I can't figure out the width here. And since I don't know the height or the width here, then I don't know the height or the width here. All right, what I do know, though, is that the height and the width of this one have to multiply to get what? 6. So I'm going to have something times something here that's going to give me 6. Let's list out those choices. What are the ways we can multiply to get 6? Jordan? Okay, we could do 2 times 3. So if it was 2 times 3, that would mean that the height of this one is 2 and the width of this one is 3. All right, what's another way we could get 6? Okay?
6 times 1.
6 times 1 would mean the height of this one is 6 and the width of this one is 1. Okay, what's another way I can multiply to get 6? It's a trick question, and it does make a difference here, because if I say the height is 2 and the width is 3, that's different than saying what?
6 times 2. I mean, 3 times 2.
3 times 2. It's different from saying that the height is 3 and the width is 2. So these are two different things here. One of them says that the height is 2, the other one says that the height is 3. And there's actually one more. What is it? What are we missing? 1 times 6. All right, so the first number, remember, the first number is always the height and the second number is always the width. So 1 times 6 is different from saying 6 times 1. This one has a height of 1 and a width of 6. This one has a height of 6 and a width of 1. All right, so what we're going to do now is we're going to start just guessing and plugging stuff in and seeing if it works. Okay? At this point, I would recommend using a pencil or writing it in a way where it's easy to scratch it out and change it, because there's a good chance we're going to guess wrong. All right, so let's guess first that the height is 1 and the width is 6. I'm just going to go down the line here. So if the height is 1 and the width is 6, then I can say that the height is 1 here and the width is 6 here. All right, let's see what happens if we do that. If the height is 1 and the width is 5e for this rectangle, what's the area of this rectangle? 5e. And what's the area of this rectangle? What's 2e times 6? 12e. Did this one work?
No.
Why not? I know this one is wrong. How do I know it's wrong? When I add these two areas together, it should give us what? 19e. What is 5e plus 12e?
18e squared.
17e, right? So these add up to 17e, but they're supposed to add up to 19e. So I know that the 1 times 6 is wrong. All right, so let me erase all this. That's why I said we need to do it in pencil. And I'm going to scratch out that 1 times 6, and we'll try again. So let's try 2 times 3. So the height is 2, the width is 3. So we plug in 2 for the height here, and we plug in 3 for the width here. Does everyone understand why I'm doing that? So if the height of this rectangle is 2, then that means that the height of this rectangle is also 2. And if the width of this rectangle is 3, then the width of this rectangle is also 3. All right, so let's check this one out, see if this works. What's 2 times 5e? 10e. And what is 2e times 3? 6e. Does 10e and the 6e add up to get 19e? No, so that one doesn't work either. Let's erase all that and scratch out the 2 times 3. Let's try 3 times 2. Height is 3, width is 2. So where's that 3? Where else is that 3 going to go? That's the height, so it's going to go with what other rectangle? The one on the left of it. So that's going to be here. and then the width here of 2 is going to be the same as the width of this one, which is 2. Okay, let's check this one out. 3 times 5e is 15e, and 2e times 2 is 4e. Does that one work?
Yep.
Yes, we got it. All right, so the one that we're going to use here is the 3 times 2. All right, so I need to finish this up now. What do I need to put as the height out here? What's the height of this rectangle? It's also the height of this rectangle. 3. Now this is where, remember when I said it makes things easier if you always write the height first and the width second. So if the height's always first and you're looking for the height, you know you just look for the first factor here. So the 3 and the 3 are both the height, which is going to go out here for the height. And then the width is second, so the width of these two is 2, which is going to go up top. All right, now we can use that to fill in all the blanks. So what's going to go up here with the 2e?
3.
The 3. So we have 2e plus 3 for the height. And the width is 5e plus 2. Now, when we did this one, especially when we were doing that guess and check part, which we really can't avoid that right now, what we did is we plugged in numbers, and then if it didn't work, we erased it, scratched it out, and went on to the next one. I don't really like writing stuff down and then erasing it, and then writing stuff down and then erasing it if I can avoid it. So if you feel comfortable with it, you could just kind of mentally plug it in, put the number, the height here, put the width here, and see what they multiply to, and make sure they add up to this middle term here. And you can do that then without actually writing those down. All right, go ahead and give this one a try. At least get started with it, and we'll go over it together in a couple minutes. All right, so I'm going to go through and just write in everything that we know, and then we'll figure out everything we can do without guessing, and then we're going to have to do some guessing. All right, so first of all, this first factor is the height, second factor is the width, and then the answer here, that's going to be the area. So the height, I know part of that is 3f. I can put that in there. For the area, which one of these terms is going to be split up between two rectangles? That 43f. And which two rectangles is it going to be split between?
Top right, bottom left.
Top right and bottom left. All right, so it's going to be these two rectangles right here are going to add up to 43f. The 12f squared is going to go where? Top left. And the 35 is going to go bottom right. Okay, so that's everything we know from the problem that was given to us. All right, so now let's figure out what we can from that information. All right, so I know that the height here is 3f. So that's the height of this rectangle and the height of this rectangle. So I'm going to put that height in both of these here. So it's 3f. And notice I'm putting times a blank there. So it's going to be height times width, and I'm just putting a blank there for the width so that I can fill that in when I get the opportunity. All right, so those two heights we know. And then using that, what can I figure out? Looking at this rectangle right here, anytime we know two things about that rectangle, we can figure out the third one also. So I know that the height times the width equals the area. If I know the height and the area, I can figure out the width by dividing that. So I multiply 3f times what, Ryan? 12f squared divided by 3f gives us 4f. All right, so that gives me the width of that rectangle. Again, anytime I know two things about the rectangle, I can figure out the third. And since the width of this rectangle is 4f, where can I label that? Up on top. So this is going to be 4f. And then I also know, since the width of this rectangle is 4f, what other rectangle has a width of 4f? The one right below it, right? Those are the same width. So this one's going to be something times 4f. Now, is there anything else we can figure out without doing any guessing? The problem we've run into here is we know one thing in this rectangle, but not two. We know one thing in this rectangle, we know one thing in this rectangle. Remember I said if we know two things about a rectangle, we can figure out the third. But if we only know one thing about each of those, we can't figure anything else out for sure. So at this point, we're going to have to start guessing. All right, so I'm not just going to guess randomly. I'm going to start guessing things that make sense, and I'm going to look at this rectangle to figure out what we'll guess. So I know that the height times the width here will equal 35. So Alejandro, what kind of options do we have for the height and the width here?
Height and the width.
Uh-huh.
7 times 5.
Okay, could be 7 times 5. What else? 5 times 7. What else? 1 times 35, and one other. 35 times 1. Again, 1 times 35 and 35 times 1 are different. All right, one has a height of 1 and a width of 35, so it's a really wide and long rectangle. The other one has a height of 35 and a width of 1, so it's a really tall and skinny rectangle.
I recommend like what Mr. Betts did in his rectangle.
Now we're going to have to start guessing and checking. And I'm just going to go down the line, which may or may not be the best way to do it. You can kind of jump around. You can pick whichever one's your favorite. But you are just going to have to plug stuff in and see if it works. So I'm going to start with the first one here, the 1 times 35, and see if this one works. All right, now I'm going to do this without writing it down. Let's see if we can think about what's happening mentally. All right, so if this is 1 times 35 here, then where's the 1 going to go? Is the 1 going to go here, or is it going to go here? It's going to go over here, right? So 1 times 4f gives us 4f. And then the 35 is going to go here. 3 times 35 is 105. So we have 105f plus 4f. Is that 43f?
No.
No. So that one's not going to work. All right, so we figured out that one didn't work, and we didn't have to write anything down. It's not a terrible thing to write things down, but if you don't like writing it and erasing it, then you'll need to be able to do it this way. All right, let's try the 5 and the 7. If I plug 5 in here, 5 times 4f gives me 20f. And the 7 in here, what's 3f times 7? 21f. So we have 20 plus 21 gives us 41f. Does that one work?
No.
No, it needs to be 43, right? It's close, but close doesn't count here. All right, so let's try 7. 7 times 4f gives us 28f. And 5 times 3 gives us 15f. What's 28 plus 15? 43. Does that one work? Yes. So that 7 times 5 is going to be the one that's going to work out for us here. So I'm going to go ahead and fill that in. This is going to be 7 times 5 here. This is going to be 7 times 4f here. And this is going to be 3f times 5 here. Does everybody understand how we got that? And really what we did is we were mentally just plugging those numbers in without actually writing them down so we don't have to erase them if they're wrong. All right, so let's go ahead and finish the area model. There's a few things we need to do here. 7 times 4f is 28f. And 3f times 5 is 15f. All right, so we've got all the rectangles done, right? Just scan them. We see height, a width, and an area in every one of them, so that's okay. But we're not quite done with these models because I need to label what?
Yeah, width and height.
Yeah, the width and the height. So the height of this rectangle is going to be what? 7. And the width of this rectangle is going to be 5. Okay, last thing we need to do now that we have the area model done is just fill in the blanks. What's going to go here with the 3f?
7.
That's the 7. That's the height, remember. So the first factor is always the height. 3f plus 7 is the height here. And then the width is
4f plus 5.
4f plus 5.